All right, I have to start by saying I bring my own biases and assumptions to this discussion, so, and no pun intended on that. For my biases, I'm all in on the rapid pace of innovation in AI. By the time I'm done with this talk, there's been probably a dozen more white papers for deep learning. It's dizzying. I can't keep up, and I'm a practitioner. I like to call myself one. That said, I'm also acutely aware of the socio-technical issues where, there isn't enough governance in what we do, or I would assume some of you are trying to do. How many people here are in the field of machine learning, whether it's deep learning or, there you go. All right, so I said biases and assumptions, so I guess I owe you assumptions. Assumptions, I assume that everyone in this talk at least understands what AI is. If not, I can give a quick primer. And I'm going to be talking about the deep learning application of machine learning here today, and in a weird way. This is a kind of unconventional talk. I'm going to start with a story. It's 2004. I'm working for the then Office of the Governor in Richmond, Virginia. That's this beautiful picture you're seeing here. I did not take this picture. I do not know who to attribute it to. It's lovely. I finish work, change out of my work clothes, get my gym clothes on, and start my half-mile trek walk between the Capitol building and my gym. City, right? So lots of one-lane roads. I'm crossing, got my headphones on, 2 patrol cars come in like hot, like full force, block my path, guns drawn. I'm like freaking out because all I wanted to do was some squats. And so I squatted, got on the floor even before they said something, or maybe they've been yelling at it because I had my headphones in. You know the story. Knee on my back, hand stretched out. Case of, it was a case of, I was wrongly identified, essentially. Mistaken identity, that's the term. So I guess it was from a flesh-based API standpoint, it was sort of a low accuracy, low precision recall from the police officers there, and I fit the description of an apparent criminal. I was wearing sweats, gray sweats, and a white tee, which in 2004 probably described half of Richmond males. There's a point to that story. I was traumatized, I still am, but thankfully nothing bad happened. I'm here, right? They let me go, and so who am I? I'm Noble Ackerson. I'm the one in the middle, in case it was hard to tell. I'm fortunate to call myself a father to those 2 wonderful girls you see. For work, I'm a product executive at a company that you may not have heard of called Venterra Corporation. It's in Northern Virginia. I focus on the responsible delivery, maintenance, and use of artificial intelligence systems. And as you may know, working with some of these non-deterministic systems like machine learning is super hard. So if you're stuck somewhere and you need help, especially with responsible AI and some of these topics that we're going to talk about today, I'm probably the easiest person to find on social media, and I probably posted my socials around here somewhere on one of the or 2 of these slides. So again, responsible AI, that's that term. Why do I work in responsible AI? I work so that my daughters can live in a world that is more equitable and fair with a software that is going to be is already commodified right now. I work in this space because, actually, let me ask you a question. What was your time to AI this morning? Okay, I'll ask it a different way. From the moment you were dead asleep to waking up, when do you think you started interacting with an AI? Pick up your phone. All right, so if AI is to be ambient, it better be fair. And I want to be a good ancestor. I want all of us to be good ancestors for the systems, intelligent systems that we build. I'm very excited to be here at Strangeloop to talk about fairness and bias, one of the 5 pillars of responsible development and use of AI. And with that, let's talk about those pillars. Responsible AI. What responsible AI means in practice is that on any given day, I'm leading my teams to leverage human-centered machine learning approaches and practices, like how to teach an AI to accept user feedback or process it, and to have that part of improving a model to make things better for us. We call that ML/UX. I've heard it being called human-centered ML. Very nascent practice. I'm also helping teams. Take this annoying thing right there off. I'm also helping teams define what fairness means for their machine learning use cases and to debias learned models as best as we can. I'm implementing human interpretable models that are complete, accurate, and meaningful, as well as consistent explanations across equivalent models. For example, you sometimes hear that called explainability or XAI. The last time I was here at Strangeloop, I gave you a lens into designing and delivering privacy-preserving machine learning capabilities inherited from your data and AI governance practices and policies. And at this rate, I need to come back here for maybe 2 more of these types of talks to round it out with all the 5. Today you get a twofer, actually. And then the last one is more security and robustness, where we're designing things that are secure and robust and can't be taken over by adversarial actors, for example. So again, you get a twofer today. I'm going to be talking about both bias and explaining why why a machine learning model is predicting what it is doing, because you can't change, you can't improve or debias without understanding what's going on with a traditional black box model. So let's get started. So I asked that question, your time to AI, and I got chirps, and I said, if AI is to be ambient, it better be fair. It kind of took a few seconds for some of you to figure out what was my time to AI this morning. And if it took a few seconds to figure out which features on, say, your phone was powered by AI, then perhaps the value it delivers behaves fairly. At least it behaves well, right? Do we agree with that statement? That said, throughout your day, you may have interactions where you may need more context on why a recommendation was made, or why you, on the flight here to Strangeloop, perhaps, you were flagged as a suspicious traveler. That has happened to me many times. But I get no explanations. I don't understand. It's black box. Maybe someone behind the curtain might understand, but not me as a consumer. Machine learning teams want to know this as well, like the lens into an input's effects on a prediction. Also, your legal team want to know, especially when things blow up. If it's on the internet, something inevitable is going to happen, and your legal team may want to sort of clean up the mess, or if you're really unlucky, regulators might come knocking. You need to explain that. We'll get into that. Which brings us to bias and fairness. Like, how do you assess what fairness means? It's a tough question, and there's no single definition. Actually, there's no case law in the United States that has a single definition of fairness, which makes this talk, Useless? I'm sorry. We'll keep going. No, sorry. When we talk about fairness, though, we're talking about individual fairness in the broadest sense, seeks for similar individuals to be treated, well, similarly. When we talk about group fairness in its broadest sense, it segments populations into groups defined by what we call protected attributes or protected classes, legally protected classes, at least in the United States. And looks for some statistical measure to be equal across those groups. In theory, it works, but in practice, it's kind of tough. Common applications of fairness falls in healthcare, human capital management. So if you've ever read anything on the internet, you've probably heard about Compass, something about recidivism, people, automated decisions to make sure someone won't reoffend and go back to jail, that kind of stuff. I promise I'll spare you those examples because you can always Google those. Law enforcement is a big one, right? Predictive policing, which Justice Department, trying to prepare for this talk, I'm like, how many predictive policing startups are actually being implemented by local law enforcement? And there's a paper on this where Justice Department admits they don't really know how many predpol AI products they've actually funded, which is kind of scary. Fairness is hard. You can't, it's hard to mathematically quantify. And so a lot of researchers have done the grunt work of creating some baseline metrics that we'll go over today as well. We want to do our best to have AI act as fairly as possible. Not just for socio-technical reasons, but it's just good business, right? Think of, if you're familiar with a typical machine learning workflow, one of the final steps once you've served a learned model into production is to monitor for drift or skew. I'm going to go on a leap, and I'm going to just say here, and some of you practitioners and academics in the crowd are probably going to, pull me aside and tell me I'm wrong. But bias is a form of skew. It's noise. And when you're trying to run a business, you do not want noise. It's just bad business. So it affects your quality of service. You want to treat people well. You want to sort of scale. Again, good business. You want as many people to use your product, adopt your product, so you can get your magical product market fit. You can't do that if you're excluding or you're treating people unfairly, unintentionally. And then there's this concept of traumatized data. I credit that phrase, it's kind of dramatic, but I credit that phrase to one Nicole Turner-Lee. She's a wonderful sister out in DC. She works at Brookings Institute. She talks about how trauma in the sense of collective psychological, emotional, and cognitive distress experienced by an unprivileged class, a group, such as African Americans, affects the AI models we use. So these are a few popular metrics we use to measure fairness in the same way you would assess, say, the success of your model using a confusion matrix. This is a screenshot from IBM research, and this is some of I think there are a few more metrics that you use to guide what fair means for your context. If you want to take a second and are very interested, I'll make these slides available for you as well. All right, I wish I had some water. Do we feel humans are perfect? It's a leading question, loaded. Humans aren't perfect, right? I feel we encode, or better yet, propagate our biases in the data we use to train AI. I'll give one example with historical bias, tying that back into the point of that Richmond, Virginia story where the cops pinned me down mistaken identity thing. Police, as I hinted at, departments use algorithms to help figure out where to send resources. It's very hard to find numbers on how many police departments do. However, machine learning algorithms today are mostly all correlative, right? They're not causal. The algorithm doesn't understand if an arrest was unfair or unjust. It just sees an arrest. You're a saint and a scholar, sir. Thank you. It just sees an arrest. And the algorithm is going to send police to where it thinks the crime is. But on its own, it won't understand that traditionally this is where police have sent resources. For example, neighborhoods where a lot of people look like me. Therefore, that's where the AI sees the crime. Therefore, that's where the police see the crime. In some cases, egregiously unfairly. Like two African-American brothers just sitting at a Starbucks and getting arrested, only to be released, and Starbucks releasing this apology. Therefore, that's where they've made arrests. Therefore, more resources are sent there. Therefore, the data that we have access to is traumatized. And the output of a machine learning algorithm leads to more prejudice, assumptions, stereotypes based assumptions, leading to new harms amongst groups or individuals. It is the worst flywheel one can ever imagine. Seriously, there's startups, Clearview. I'm sorry, does anybody work for Clearview here? I can talk shit about them? Okay. There are companies, there's startups out there thinking they've cracked precognition from Minority Report. It's pretty scary. Bias is a way to shortcut decision-making at a subconscious level. I'm not talking about statistical bias, I'm just talking about bias. It's human. But it's reflected in the data that we collect. Right there. So these are the types of bias there. This is from a Cornell University paper. Yeah, I'm using the socio-technical angle to make a point and also to intentionally make you uncomfortable, if you are, or just to drive the point home. But know that these techniques and tools that I'm talking about can be applied to, frankly, any group of things, right? Think about it. Netflix or Amazon recommender systems, for example, they suffer a lot from popularity bias. Do you know how many things you might have missed because of what was pushed in front of you? It also leads to harm. Think about it. Your social media feed, that filter bubble we keep hearing about, and misinformation, disinformation, or malinformation being sort of subverted, the systems being subverted. Bias starts in the data. The algorithms transmit it, and the users are susceptible to harm because the outcomes don't reflect the world we like to live in. Because deep learning applications, machine learning applications generally, one, are correlative, not causal. They're also non-deterministic. We bias the inputs. We need to bias the inputs to get the desired results. We bias the inputs or outputs, whether you're pre-processing or post-processing, in order to get the desired results that we want to. And those familiar with like deep learning, neural networks, for example, we include randomness, right? We include weights, we include biases to each neuron on purpose so that a neuron can fire, for example. Similarly, we apply algorithms during pre-processing, during pre-training, pre-processing, during in-processing, so while you're training, and then of course on the labels or on the prediction itself, post-processing phase, to provide our desired definition of fair. Because with deep learning, there's no guarantee that that provided input will provide exactly the same or expected output. We need to scrutinize and have the systems that I'll go over here in a second. Don't worry, there's going to be techie stuff. We want to make sure we don't harm people, essentially. In the next 30 or so, maybe less than that, 20 or so minutes, I hope you take away that fairness and bias is hard, so that yes, when Facebook's chatbot goes rogue, know that there are humans behind that, and no, Facebook as a monolith is not racist. These are hard problems. These are hard problems that affect consumers, you and I. They affect the data scientists and engineers in the room. They affect policy and stakeholders. And this entire talk is framed around these three stakeholders. But because I've already put you to sleep, I'm going to start with policy. All right, so for policy, you want to increase trust with policymakers. You want to reduce scrutiny, and you want to innovate. You want to show that you're being good stewards. And if something happens, you're able to explain it and have certain policies internally to sort of catalog or report against things that may be going right or things that are going wrong. So you increase trust by simply being responsible in the development, the delivery, and advocating for and listening in for the responsible use of the systems that you build. Getting regulatory eyes off your company leaves you to innovate. I mean, that's not a controversial statement, right? If you're doing the good thing and you have a brand trust for being good stewards of users' data, yeah, you'll see Congress parade Google, Facebook, and somehow Tim Cook or Tim Apple is not in front of Congress. Sometimes he is. I think they're doing ads now in Apple News. It builds data trust in your customers as long as you're responsible in the delivery of the systems and you're delivering good value, right? It's just ambient. The AI is working for you. And you wake up and by noon, you've used like 70,000 AIs and you have no idea. It's just obvious good business sense. I'm going to use one of those examples that I promised I wouldn't use, but this is important to make another point. So Amazon, a few years ago, decided to roll out same-day delivery. And yes, Amazon, with all the PhDs and talent, makes mistakes. They can afford to make mistakes. If you're a startup, maybe you can't. They have an army and infantry of attorneys. And so stop me if you heard this one. Amazon chooses 6, maybe more. This was what was in the paper. Cities to roll out same-day delivery. The blue was where they decided, their AI decided to provide coverage. The gray was where they decided to not cover in the initial rollout. Roxbury, if we look at Boston Township, was excluded. You know where this is going? Eerily similar to redlining maps, where lenders had identified Roxbury as hazardous. But to Amazon, they still got fined. because failure of fairness through unawareness is no excuse. Perhaps Amazon was just predicting the number of purchases. Amazon's not racist. Amazon's not a thing or person, right? People come into work every day trying to do good by you and I. They were just predicting the number of purchases the AI was trained to. Unfortunately, the number of purchases in a given locale correlates with affluence. Still good. Which correlates with, in some cases, race. And in the US, race is a protected legal class. Amazon almost certainly did not look at a customer's race when they built this product. This is called proxy effects, secondary effects. So, Congress comes running. How does Amazon then explain to regulators, I promise we're not racist? I remember I promised you a twofer. I'm going to take a tangent and talk about explainability. Regulators are increasingly requiring model explanations when things go wrong with deployed models. Simple models are often inherently interpretable, but as models become complex, for example, deep learning examples or ensembles of models, being transparent, trying to understand what's happening becomes a little bit more difficult. Traditionally, complex models are often described as black box models. All right, I don't like that term, but it's opaque. We don't know what's happening, and historically we've accepted it. But I'm so glad that since I started giving this talk, more and more ecosystems and platforms have started including ways to explain it. So that's promising. With transparent models, we look to explain what a deep learning model looks at to make a classification, a recommendation, or a prediction by highlighting feature importances on an input. Again, this is good for explaining why I got flagged as a consumer, why I got flagged as a problematic traveler, or why your model is behaving in a certain way for a data scientist, or explain to Congress why we left out Roxbury. So we look at certain tools like Lime, integrated gradients, or in this case, SHAP. SHAP stands for Shapely Additive Explanations. It came from Microsoft Research. I believe Scott Lumberg et al. I know Scott Lumberg was one of the contributors, inventors of this tool. It's pretty cool. It applies game theory to explain the output of a machine learning model. SHAP offers a library of visualization options so that you can explain which feature is important, or which features are more dominant. So we're showing, let's say, the mean absolute value or the SHAP value of each feature at a global level. In this case of the visual on the right, you're looking at something called a waterfall plot that depicts a plot of the classic Boston housing data set. If you've ever been on Kaggle, you probably looked at that data set to predict house price per a specific locale in Boston. And here we're explaining why the model made the prediction it made. Note that the blue arrows reflect the lowest impact on a model's prediction, whereas we see the poor areas of Boston drive housing prices. They call it LSAT, like the percentage of lower status of a specific population. Using SHAP, we're looking further than coefficients of the model. We're using training data to give impact of each of these features. So rooms, taxes, crime per area, the age. You can see that LSTAT, the lower status areas, have the most impact to the feature's prediction. So these are some questions to consider. Again, the visual you see on the right here are in the US anyway, the legally protected classes. I think there's some overlap with the EU as well, if you want to do business there. But these are some questions that you might want to ask. Does our use case require legally protected classes? In some cases, yes, right? You're a bank, you need to know the age of your requester of a loan to give them a loan, for example. So there are justifications to do that. Are there secondary effects? Could there be correlatory reasons why, even though I'm not using skin color, that I can infer skin color through a secondary effect? And, am I, harming someone, essentially, which seems like an obvious question, but a very hard answer to get to. So that's policy. Again, you're trying to avoid representational harm. You want to reduce the amplification of stereotypes in that case. You want to prevent opportunity denial. And frankly, my favorite as a product manager, disproportionate product failure, because it just doesn't make good business if I'm building this and I want to expand, excluding folks. The part that I've been told Strange Loop is here for. Let's talk about the machine learning team, how we increase data and model understanding, create better algorithms, and produce robust models. So here I'm going to sort of show the typical workflow of a machine learning process. To fight AI bias, we introduce a variety of algorithms to discover where the bias might be, to mitigate bias. For example, within a typical machine learning lifecycle, you may want to have a way to understand black box classification of a regression model, right? So you might want to do a counterfactual. What would happen if? TensorFlow has that as part of their TFX pipeline. And so you can probably run a what if analysis on that and for different scenarios as to how additional data being introduced or additional models being introduced from, say, user feedback could affect your model. For bias detection and mitigation, what algorithm you use depends on whether you want to fix the data itself, call that pre-processing, fix or test against the classifier or training, so in processing, and or lastly, the predictions or the AI recommendation itself, so the post-processing algorithm, right? By pre-processing, we run tests on the data itself. Like, so say, for example, if you can modify the training data, like you have access to the training data, then a pre-processing algorithm can work. There are a few of them. Reweighing algorithms. I'll provide if you're in the Slack on the channel, just to see how I do with time, I might just start throwing my notebooks and some of my resources on there. I've already started, so make sure you look for this talk in Slack, that channel or whatever. I dropped part of the demo portion for this. By in-processing, we mean the algorithm. Oh, yeah, I didn't realize I did that. This is from last week's talk. I gave the same talk last week, so here you go. You can scan that as I talk. By in-processing, we mean, oh, by the way, the security folks, this is, I promise, not. This goes to IBM's AI F360, where a lot of my research comes from. Trust me. By in-processing, we mean an algorithm to mitigate bias that is applied to the model. There we go. The model during training on a classifier. So here, if you can modify the learning algorithm, then an in-processing algorithm such as adversarial debiasing or something like that can be used. And then by post-processing, we mean we test for bias against predicted labels. Basically, here we're just messing with labels to address the harms in an underprivileged or a protected class. By the way, this is also typically where you would try to explain your prediction, again, in that evaluation stage of your workflow. And you don't have to use SHAP. I like SHAP because the visuals are pretty and the algorithms are a little bit more robust, in my opinion. If you're doing a lot of images or videos, you might want to use integrated gradients, for example. Lime is also bundled in a lot of these bias mitigation algorithm or the toolkits or the libraries, like AIF from IBM Research. Fairlearn, I believe, also uses Lime. Fairlearn is from Microsoft Research. As you would normally do after you've served and you're monitoring your model, monitoring and debugging, again, for me, model skew is a form, bias is a form of model skew. Another way to look at this and to internalize this, how this fits into the typical workflow, I want to quickly give a refresher. The process starts with a typical process of a supervised machine learning process starts with training your data set. Well, it doesn't start there, but I'm cutting some corners, which contains a sequence of instances where each instance has two components, your features and the correct prediction of those features or for those features. Machine learning algorithm is trained on this training data set to produce a machine learning model. A second data set, which with features and correct predictions, we call that a test data set, is used to assess the accuracy of the model. And then a random partitioning of a random partitioning algorithm, I actually don't know how that works, not that deep, is used to split the initial data set into training and test data sets. Bias can enter the system in any of the three steps. Right? So let's look at it in action. Let me see. How are we doing on time? It's 11:30. I have until. I'm going to put this notebook. I'm going to flag this part, and I'm going to put this notebook on our Slack channel just to save time. Is that okay? All right, let me do that. Let me do that instead. All right. So I've been looking at some of you guys as I talk, and I can spot folks that do this day in and day out. I have to admit, I call myself a practitioner. I lead teams on the federal side and then on the commercial side at my company. So I'm not building, I do model fit every day. So I'm seeing some of you who are rolling your eyes. It's like, there's a trade-off, there's a catch between optimizing for bias, because something's got to give. If you optimize for bias, you sacrifice performance. And you can also sacrifice accuracy. It's like a squeeze toy, right? One impacts the other. In a typical machine learning objective, you want to solve an optimization problem, right? The goal is to minimize the error. In order to get to fairness, our objective is to solve a constrained optimization problem. So there's a tension there. It's actually why my team hates it when I come in with all the ethics talk, right? Because they just want to get it out, get the product out. So rather than say, I'll give you an example of what I'm trying to say. It's like, if I say, like, find the model in my class that minimizes the error, rather than saying that, you'll say, find the model in my class that minimizes the error subject to the constraint that none of these, say, 7 racial categories or whatever the protected attribute you want to solve for should have a false negative rate more than, say, 1%, different than the other ones. And it comes that, but that might sound like a mouthful. All I'm trying to say comes down to this. From what we've learned from our model, is our data model doing good things or bad things to people? What is the likelihood of harm? And so just internalize that, the importance of this. And for those who are wondering, this is not my art. It's impossible for me to attribute it to a human. I just put in a prompt in Midjourney, a face-off between accuracy and fairness. Those who are paying attention, half of these slides are generated by AI. But I'm not an AI, I promise. All right, because deep learning applications, I've said this once already, I'll repeat, are non-deterministic, we need to bias the inputs or the outputs to get our desired result. How do you define fairness for one solution will be different for another. And human-centered practitioners leverage those comprehensive set of metrics that you saw that I shared before to solve this. I'm going to breeze through consumers and end users, but it's important. I was actually going to cut out this entire section, but I kept it in. You want to avoid over-trusting or under-trusting with the solution after it's integrated into software. Your machine learning model is integrated into software. Because people need to know when they should use the AI without question or whether to use their own judgment. When dealing with people's lives, though, for example, with law enforcement, if you undertrust the officer, judge or whoever that's leveraging the AI, will waste time searching for additional matches for a perpetrator or what have you. On the extreme end of that, if you overtrust an AI's prediction, the wrong people will get arrested or even worse, killed maybe, when an AI recommendation is wrong. So for the researchers or user researchers that are hopefully part of your machine learning team, you want to sort of calibrate your trust factor. We call that calibrated trust. Things are going to explode. Things are going to go bad before you serve your model, when you serve your model, and perhaps after. So you have to manage your users' expectations. You want to align feedback with model improvement. You want to do these 3 things: designing mechanisms to request feedback, building functionality to respond to said feedback, and interpreting implicit meaning sort of psychographic analysis of data that you might have, their preferences, their likes, or explicit, I like this movie, thumbs up, 5 stars, what have you. For explicit feedback, the user needs context on the level of confidence of a prediction, recommendation, or classification, whatever decision that the AI is outputting. Here, leveraging what you learned from SHAP or some explainability tool could be boiled down and explained like I'm 5 to a consumer. I've been told I'm running out of time, so these are some takeaways. Debiasing techniques Also benefit non-protected or underprivileged classes. It's just noise, so consider some of these tools and techniques. Some of these packages that claim to help you out with debiasing your data sets suck. So AIF 360 notoriously has terrible support. I've been shilling, I've been sort of pushing it, but look at larger ecosystems, unfortunately, like TensorFlow or Microsoft Fairlearn. So I want to end with this. After 2 years of doing research in this space, this is how I define fighting bias with bias. It's what was, what is, and what should be. With what was, an acknowledgement that we aren't perfect, and left unchecked, we propagate our biases in the models we train. With what is, recognition that we already introduced bias into the process to improve performance, accuracy, and optimizing for error. And what should be, by that I mean putting these into practice, tooling and approaches that I've talked about today, in efforts to solve these constrained optimization problems as part of your workflow. Making these hard trade-offs and having these hard conversations to avoid disproportionate product failure, representational harm, or opportunity denial to the groups or individuals. I hope we collectively use these tools and techniques so that we're better ancestors in this practice, so that my daughters can have a better lived experience online with some of these tools that we use. Thank you.